Perfect. All right. Yes, and welcome to the last presentation for today. Yeah, my name is Miriam Mitterfellner. I'm working in here since last year as sustainability manager, and yeah, I'm going to tell you about sustainability in the context of research infrastructures, and therefore I'm going to first tell you about so why do we need sustainability research, especially in the battery context. And then I'm going to show you what measures we here at the FFB are doing to increase our sustainability. So let's start by looking at the greenhouse gas emissions in the EU over the last few years. And yeah, to spread some optimism, we can see here that the overall greenhouse gas emissions over the last 30 years, they have drastically decreased from almost 5 billion tons CO2 equivalents to 3.5, which is yeah, good news for today. But when we look here, wait, I'm going to use my pointer. But when we look here at the emissions from the transport sector, we can see that emissions over the last few years have steadily increased. There was a slight drop during to Corona, but yeah, we've seen that during to growing individual transport, the emissions from the transport sector have been increasing. So let's take a closer look at these emissions. So when we break it down, the transport sector makes up 21% from EU greenhouse gas emissions. And out of this transport sector, the main contributor is from road transport. And if we further break down the road transport, we can see that most of the share is due to the passenger transport. So what does it mean? It means that if we aim to decarbonize this sector here, the passenger transport, also the others, but it's focusing on the passenger transport, we are actually having a huge lever to decrease the overall greenhouse gases in the EU. So let's take a further look at these numbers. So right now we have in 2020, we have 329 million tons of CO2 equivalents emitted each year, so in 2020. And yeah, I think we all know that the EU has set some very ambitious targets to cut down these emissions. And the target is a 90% reduction in greenhouse gases in the transport sector. And if we transfer this number to the passenger transport sector, we would need to decrease our emissions by 276 million tons of CO2 equivalents. So that's quite a big number. So what are the answers to this problem? And yeah, we've already heard it today a few times. We need to electrify our transport sector, and to do that, we are quite on a good track here. So we can see that in 2020, out of all new car registrations in the EU, they were electric vehicles, and we can also see that from this share, the majority was from electric vehicles rather than plug-in electric cars. So yeah, we're here quite on a good track to reach these targets. But if we're looking again at this number of greenhouse gas emissions reduction that we need to reach, the question is, at which costs do these reductions come with? And so I want to show that in a very simple calculation that when we're aiming at increasing the number of electric vehicles, we also need batteries for these vehicles. And so around about 104 million tons of CO2 equivalents are emitted if we are producing 10 million vehicle batteries. So this number is based on the yearly number of new registrations for new cars, which is 50 million each year. So if we're taking, or if we're suggesting that 10 million of these vehicles are electric vehicles, we will come close to this number. So let's look at how is this number, so where does it come from? So here we can see that the greenhouse gas emissions from producing 1 kWh of battery capacity. And the main contributor here is with 40%, or like 60% is from the materials, and 40% is due to production energy. And now, of course, we have to ask ourselves, okay, is this a reliable number? Can we really use this number to make such a projection? And yeah, the short answer is no, because as we have it in the research, if you ask 10 different researchers, you will get 10 different answers. And this is exactly what my colleagues did an investigation on the energy consumption in the battery cell production. So here again, we have the CO2 equivalents per kilowatt hour produced capacity. And here we can see that we have a huge variety in numbers. And so what the colleagues found out that their number is again like the lowest that they found in the literature. So why is that? Of course, that's if we're looking at different locations of production, which is closely linked to different energy mixes. Of course, the system boundaries that we're looking at. Also the assumptions on the process, or are we looking at industry scale or are we looking at lab scale, for example? Also the assumption on the product itself. So what is the energy density, for example, from the battery, which type of battery, and which calculation method was used for this study, and are there any kind of criteria? And yeah, so what they found out that probably the number on energy consumption in the battery cell production is heavily overrated. When we again look at the number for our emissions, then we can see that with the new number that the colleagues have found out, that the number of greenhouse gases can be reduced dramatically. So that means that also this number here will decrease a lot. And so what we can see from that is that we really need reliable industry data to make such projections or to make any forecasts. And this is where there's a huge gap in the research. And this is where the Fraunhofer FFB fits in perfectly, because we have the capabilities to provide such data. And yeah, so we can validate and generate data for sustainability research. But let's look at, okay, where will this number here show up in our greenhouse gas emissions balance? So it won't show up in the transport sector. And depending on where the battery has been produced, so if it has been produced in China, for example, this number won't show up at all in our emissions balance. And also this number will only partly show up because when we so we've heard it already in a few speeches today already. In Europe, we have a lot of production sites that are going to be be set up. So this number here will going to show up in the industry sector, in the emissions from the industry. And so, but not all of this number, but only the part up here, the production energy, which for the emissions from production. And this part, yeah, depends on where the materials are coming from. And so the question is, what can we do to further decrease this amount here for the production energy? And this brings me already to the next slide, where we're gonna see or have a look at the greenhouse gas accounting. And I'm sure many have already heard of the different scopes when it comes to greenhouse gas accounting. So I will only go very slightly into it. So we have, when we're talking about greenhouse gas accounting, we have the different scopes. We have the direct emissions that come from the production or from the vehicle fleet. Then we have the scope 2 emissions, which are generated from the electricity supply. And then we have the upstream and downstream emissions, which are scope 3 emissions. So on these, so this can be, for example, raw material transport or also the use of the product. And so we can already see here that we have the system boundary for greenhouse gas accounting, and we include only scope 1 and 3, which are mandatory. Of course, we have to look at scope 3 as well, but if any company would focus on their scope 1 and 2 emissions, the scope 3 emissions would directly decrease for any other company as well. So let's look at what are we doing to tackle our own emissions. So in scope 1 emissions, we have switched from natural gas to green hydrogen or to electrification of our production line. And we are also installing solar panels, heat pumps, and energy storage systems to further enhance our own electricity generation. And then we will provide charging stations for the electrical vehicle fleet. And also, of course, we're researching on innovative production technologies, which will also increase the energy efficiency for our own production. So when we're looking at scope 2, then we will switch, or like all Fraunhofer institutes will switch to green energy supply. And we're also engaged in a PPA from basically next door of a solar and wind park. And then for our scope 3 emissions, we are establishing a tracking system for resource flows. And this is very closely linked to the digital twin, which we have now heard a lot from Kevin. And yeah, we're also doing a lot of research on new materials and configurations so that we can further decrease our material consumption. And then we're gonna also tackle the scrap reduction, what we already have heard. And then I'm gonna talk, we have a look at the scope 3 emissions a bit deeper on the material side. I'm quite sure many of you have heard from the critical raw materials. And here we see all critical raw materials from the EU. And we can see that, for example, cobalt, natural graphite, phosphorus, and here is manganese. It's on the brink of being a critical raw material, and lithium here. Yeah, but they're all used in batteries. And to meet the future battery demand, for example, for lithium, it will be 16 times higher, and for cobalt, it will be 5 times higher compared to the current supply. And yeah, this is closely linked to the production scrap, because we see that we have highly valuable materials that we're using in the battery production. But at the same time, we see that in Europe, the number that is available for recycling from batteries, it will be dominated by production scrap. So yeah, production scrap is a really hot topic in the battery cell production, and therefore working to reducing the scrap through digitalization is one of the focus areas at Fraunhofer FFB. And so let's see it. How can we measure the sustainability of batteries? We can do that by the method of life cycle assessment. So the life cycle assessment takes into account the whole life cycle of a product or of the battery. And therefore, we can, for example, assess the sustainability of different supply chains. So we can see, is there one material that is more sustainable than the other? We can look at the production itself. So what are different cell configurations and different production technologies, and can make an assessment or also a recommendation in terms of sustainability. And we can also assess the use of secondary material or second life applications from batteries. So what is the benefit of using, for example, recycled materials? How will it increase or decrease the environmental footprint of the battery? And all this data, like the life cycle data from the battery, it will be stored in the battery passport. So the battery passport is a control and transparency tool. We've already heard it from Kevin before. And so I will not go into much detail on the battery passport. And yeah, so for us at Fraunhofer FFB, we're looking not only at the assessment, but also at the advancement and application methods from life cycle assessment. So for example, we want to look at or to extend the scope to a life cycle costing analysis, so we can do an ecological cost benefit analysis of the battery cells. And we're also looking at automated LCA, so that we can, for example, generate the data automatically while producing and also transferring it to the battery passport. And yes, as we've heard before, we get the necessary data from the digital twin. So yes, to sum it up, sustainability at Fraunhofer FFB, what does it mean for us? On the one side, we see it as part of our DNA because we have, for example, the energy concept and also the company culture, where it's deeply like in everybody's enthusiastic about driving forward the decarbonization of our industry. And also we have it as a field of expertise and research in the terms of energy and resource management, and also in life cycle assessment. And if you have any further questions, feel free to ask.
Thank you very much, Miriam. During your presentation, there was one question in the chat, and the question is about the effect of using green electricity to reduce greenhouse gas emissions. And it says like, does not the greenhouse gas reduction requires green electricity to achieve the savings from using batteries?
I'm not sure if I fully understood this question.
It's about using, yeah, does not the greenhouse gas reduction require green electricity to achieve the savings from batteries? Just having the batteries is not enough, or the question is just having batteries not enough? It's about having green electricity or using green electricity to produce batteries, and that's the, let's say, best measure to reduce greenhouse gas emissions.
Yes, of course, it always goes like hand in hand when we're talking about also decarbonization. Of course, we need to have the green energy, and therefore we also need to have the storage to store the green energy. So it's like they're very closely linked to each other. And of course, if we produce our batteries with green energy, the effect will be better than when we produce it with coal, for example, coal-based energy.